we will be exploring about this. Let's just start without wasting time. What do you think when word is there is a word called a circle? So, what would you like to explain? How would you like to explain this? You would say this is made up of a lot of what points, a lot of points. So here, this curved shape, this curved line shape, this is closed, this is curved, this is line closed, line curved line, closed curved line, closed curved line. Now this closed curved line is made up of made up of a lot of points. Okay, already you know. So here there is a fixed point which is located at fixed point between in between here. This is a fixed point, and from here to till the circumference, this is known as a radius, which is in length, which is a distance from center till the circumference, till any point of the circumference will equal. This is 6, then from here to till here, this will also 6. From here to till here, this will be also 6. This is the meaning of radius. Okay. So, meaning of radius is a length where starts from here and it ends at any point of on this circumference is radius. Clear? So this all radius will be equal to each other. If it is measure of this radius is 6 centimeter, then measure of this line segment will be 6 centimeter. So from here you understood that all radius that are present in a circle will be equally in order to measure. Now let's understand the diameter. You already know this is a fixed. So diameter, what is the meaning of a diameter? Diameter is just what? It starts from any point of the circumference and it goes passing the center, then it ends at any point on this circumference. You can see here, just opposite. And diameter is what? Line segment, which is in straight line. Diameter will not be in a straight line. Clear? This was a exact meaning of a diameter. So diameter, it starts from any point on the circumference, then it passes the center, then it will end at any point on the circumference. Is a length is also diameter. So this is considered as a diameter. So remember, the diameter line will pass the center. This is as facility you can say. Otherwise, you can say this is a what measure point and definition of diameter. So now we understood meaning of radius, meaning of diameter. Now let's understand the chord. What is chord? This line segment of the circle is what? This is also line segment. But what type of line segment? This is chord line. Okay, this will be chord line. Remember, chord is not area. Chord is not a region. Okay, so this is chord. Okay, this is chord. When it comes to chord, then here you can see this chord line segment is not passing this center. Of course, yes. Of course, no. This line is not passing this center. So this is measure difference. This is measure difference between chord and the diameter. Kishan asked to you that tell me the longest chord. You have to tell that statement is correct or not. I am telling you. So statement is that longest chord is diameter. What would you say? Yeah, of course. Longest chord will be diameter. So diameter will also be considered as a chord if Kishan is saying there. So here, but apart from diameter, here all this, you cannot say that this chord will be considered as a diameter. No, this is a measure difference between them. So this chord will not be defined as a diameter. Okay? So this is a line segment which starts from any point of the circumference, then it ends on at any point of the circumference, but it does not pass the center. Yes, when it comes to longest chord, then of course it will pass the center. It will pass the center. Now, this is clear. This is clear. So this is chord. Now let's understand this area. What is this area? I am talking about this area. So what is this area? This is I think segment. Segment. This area is known as a segment. Whereas you can say this area is also segment. This area is also segment. So this area is less. This area is more. That's why it is said what minor. Minor which means less. Major. Minor which means you can say small. So major which means major which means major. Major which means more area. So let's understand meaning of a segment. Segment is a area. Already you are clear. And segment is formed by a chord. It is the exact meaning of a segment. Okay, segment. Segment is formed by a chord line and an arc. So here you can see this is chord and this is a minor arc. This is minor arc. So when it comes to arc, then you will define it by saying that it is a part. Arc is a part of circumference of this circle. So you can say it is a part of this circumference. Clear? Circumference. So this curved line is a circumference. When it comes to circumference, then from here you will be able to find the perimeter of this circle. We will talk about on this later. First, let's understand segment. So segment is what? Segment is an area which is formed by a chord and an arc. Here you can see this is chord and this is a minor arc, and this two a combination of a chord and an arc is giving a minor segment. Here you can also say, when we are saying this area is also major segment, then we can say that is there an arc or is there a chord? Of course, this is chord and this is major arc. So we can say this part is major arc. We can say this part is major arc, but this part is minor arc. Okay. You are clear what is major, what is minor. Minor which means small, major which means big. This was a simple meaning. Now, so here you are clear. So here you can see this region is made up by this chord and by this arc. So this is major segment. This was minor segment. Now let's come to sector. This is circle. This is origin. It is also said as center of the circle. Now, when it comes to sector, then always remember sector will be formed by two radius. And here sector will form a angle. At the center. So this area, I am talking about this area. Okay. So this area is formed by two radius. And also you can say here this is what? An arc. So without an arc, sector cannot be formed. We can say sector will form by two radius and an arc. Then it will be possible. Clear? Now when it comes to this area, then this area will be minor arc, minor sector. These are two radius and this is one arc which is minor. Now you can also see that this is also area, and this area is forming. This area is forming by two radius and by this arc which is major. So this is what major sector. This is major sector. Okay. Now from here, what will be formula to find this total length of this curved line? What will be formula? So formula can be visualized. How? So perimeter of a circle would be what 2 pi r. It is a set that let's appropriate this formula. First of all, you need to understand what is the meaning of a perimeter. Perimeter, which means peri, all sides. So there is a one side. This is not side. This is a curved line. So total length of this side, is a perimeter. So we will observe this total length, and by using this formula we can find the total length of this circle. So here, what is the meaning of this formula? It is saying this circle has a 2 pi. So from here to till here you will get this pi. From here to till here, till here is a 1 pi. Value of pi is already what as a fraction it will be considered as a 22/7. As a decimal, then it will be 3.14. This is approximately value. Okay, value of pi. This is approximately. It is also said that this is considered as irrational because this after this decimal it goes on. It does not end. And without non-repeating. It's a non-terminating with a non-repeating. Now our focus is on discussing this. So it is saying this triangle has a 2 pi. How much? 2 pi. And this 1 pi, this is second pi. And you can see this is a gap. So this is gap, which means 1 point. That is after decimal. This value is after decimal. Clear? So this is gap. And here this 1 pi, this is second pi. We have got 2 pi. Now only r. So as you know, without r, without radius, it will be impossible to find circumference. So r is also radius. R is also boundary. R is also line segment. It is not line segment. It is a curved line. Clear? So total length of this curved line and total length of this radius will be perimeter of the circle. Now from here we understood meaning of a segment, meaning of center, meaning of arc, meaning of how can be formed a sector, how can be formed a segment. Now we have understood how to find the perimeter of this circle. Now let's come on the area of the circle. Area of this circle. Now formula is pi r square, but how to believe that this is the formula of this circle of a finding area? So here it is saying we don't take common things 2 times. No, we will take a comma. Here you can see when it comes to area, you are already aware that area, which means we will apply a square in the final answer. So here pi, which means here pi is 1. So we will take pi. So here you can see there are 2 pi's. So here we are taking a pi as a common. Now next is the r square. So here it means this is r. We are taking r, and here it is saying pi is a 2 times. No, r is a 2 times. So from here, I think something you understood. So just have a look. I have some questions based on this. I have some questions based on this. Now let's accept some questions related to this. First question is saying, I will read direct from my source and you will have to answer. I will also prove that how this answer correct. So first question is saying an arc. An arc, as you know, this is arc of the circle. An arc is a dash. Okay, an arc is a dash when its ends are the ends of the diameter. We will draw a figure so that we can understand meaning of question. This is a circle, so it is saying an arc. So let's say this is arc. Is a what? Is a what? When it ends are the ends of a diameter. So it ends. So this is an arc. It starts from here, from diameter, and it's end of this diameter. So what will be considered? So this arc will be what? This arc will be what? It starts from a diameter and it ends here. So this arc is what? You would say so here from this it will form semicircle, which means half part of circle. So answer would be semicircle. So here you can see a question is saying there is an arc. So what is this? When it starts from a diameter and it ends at another end of the diameter, then what will be formed? So here you can see this is forming a semicircle of the full circle. Now next question. Next question is segment of a circle. Segment of a circle. Second question. Okay. Segment. So what is a segment? Segment is formed by a chord and an arc. Segment is a region. So segment of a circle is the region, between an arc. So between an arc, we know that a segment is formed by a chord and an arc. So here complete question is between an arc and a dash of the circle. So dash we have to tell what is in the place of a dash. So between an arc and a dash, so chord will come. So here you can see this is a segment. And it is forming by this. Chord and by this arc. So arc was given in question, but chord was not given. So answer of the second would be chord. Now next is, listen carefully. Question. What is the question? Okay. Third question is third question. Now the longest chord. Third question is the same. The longest chord. So we when it comes to the longest chord, then it will form here. The longest chord will be diameter. You already know. So it is saying the longest chord of a circle is a what? So of course it is also forming diameter. So diameter. Question is saying a longest chord is also what diameter. Now next question, which is for a circle divides the plane on which it lies. So here one point more you can understand from here. It is this circle is dividing in three parts. This outside area is exterior. This outside area is exterior, and this inside area is what? Interior. This inside area is interior, and object which is at circumference will be known as what? On the circle. On the circle. So suppose there will be three parts which will divide on the plane a circle. So three parts. How much? Three parts. Kishan was asking that how many parts can be divided by a circle on a plane. So you can see this one part, this is the second part, and third is on the circle. Third is on the circle. Now next question. You have to tell is the statement correct or not. You have to tell is the statement correct or not. Line segment joining the center to any point on the circle is the radius of this circle. So it is saying line segment. No, yes, line segment joining the center. So there is a one line segment. It is joining the center to any point on the circle. To any point on the circle. What is this? This is what is asking. So statement is what? And question is also saying that this is radius, and you have to tell that this is given statement correct or not. So statement is saying that a line segment which is starting from the center, it ends on a circle. You can say at any point on the circle. You can say this line segment, and this line segment is radius. So you have to tell, is this correct or not? Yes, of course. This line is known as what? Radius. Okay. Now second is what? A circle has only finite number of equal chords. So it is saying that this is a circle, and it is saying a circle has finity, not finity. What is the meaning of finity? In simple word, it is said that meaning of finity will be limited. So meaning of finity in other word is what? Limited. So it is saying there are limited of chord lines in a circle. So here you can see if radius is we don't know what will be radius. So of course radius can be taken as a number, any number. So of course chord will be infinity, even we can't imagine. So it will be infinity. This chord lines which are in percent of the circle will be infinity. So second statement is false. Second statement was saying that a circle will have a finite number of chord lines, but this statement is incorrect. You can say it this circle has infinity, not finity. So third step, let's jump on third statement. Third statement is if a circle is divided into three equal arcs, so each is a major arc. It is saying that this is a circle, so it divide arc. So this circle divides an arc in three equal parts. So this one, and this one. So three arcs, both of three arcs are equally into each other. Not anyone is a measure. Not anyone is a measure. So this is also. but it can be one, most three of them, one of them can be. Fourth is a chord of a circle. A chord of a circle, okay, a chord of a circle which is a twist as long as its radius. No, it is saying that this is a twist of a radius. So radius is this, and this is a twist. This is twist is a chord. Suppose this is incorrect. So radius R2 the radius R2 will form a diameter line segment, but the radius R2 the radius will not form a chord. Yeah, it is true that two radius will form a longest chord line segment. So now next question is, this was incorrect. Now next question is, next we did some question based on this circle. Now let's move on theorem related to this. One point I want to explain here is that, look, this is a circle. So here, this is a center. This is center. Now, how much angles can be subtended? Can be divided. So here, how much angles of a triangle can be formed? Here you can see this one is forming, this is one angle is forming. Now second, in this here triangle can form, here triangle can form angle, here you can see here a triangle can be formed, and like that also triangle can be formed, triangle. Okay, from here I want to discuss is that, let's say angle of this which is coming in minus sector. So angle of this triangle is let's say 36. Then it is said that whereas it is a universal truth that 36 angle of this triangle is a 36, then angle of this triangle will make a half of this, so 180. So automatically you will know that what is the angle of this if angle of this is given to you there. Okay, so this was a theorem. You can say this is universal truth that I am not talking about this, and this triangle which is forming a angle, this triangle is coming in major sector and this triangle is coming in minor sector. Okay, there is a user difference, and this triangle is coming in line segment. So now let's move on theorem. From here we understood that if degree of this triangle is given, then we can find the degree of this triangle, this angle. If a degree of this angle is given, then we can find the degree of this angle. Okay, this is what we understood. Now one point more. This was one. Now next, what is the next? This is next. Here there is a sector, there is a chord. Okay, there is a chord, and there is a point. Point is fixed, which is at the center. Is a point is fixed. Now a line which is coming from the center, a line which is coming from the center is falling on the surface of the chord line segment. So it is this is line, okay. Now it is bisecting. This line is bisecting the chords. This line is bisecting the chord. So when it comes to bisecting, then you already know this part will be, measure of this part will be equal to this part. So this is a 3 centimeters. So the measure of this part will be also 3 centimeter from here to here. This is the meaning of a bisector. So let's name it. It is a bisecting here. Now here you can say it is also forming a right angle. If there is a right angle, we can say this is forming a perpendicular. So perpendicular, which means a right angle. Okay. So you can say this angle is forming of 90 degree. This is also forming of 90 degree. And from here you will say what linear pair. Measure of this angle will make a linear pair. So where AB is a straight line. This is a separate topic. But from here we are observing. That's why I am telling you that angle ACO and sum of angle ACO and OCB will make 180 degree. Okay, will make 180 degree. So when it comes to 180 degree, so here AB is a straight line. It is a linear pair. You can see OC is a perpendicular to AB. OC is a perpendicular to AB. Here you can see angle ACO is equal to angle OCB, which is 90 degree. Clear? Which is 90 degree. What else? OC is a perpendicular to AB. Even you can say AB is a straight line. Or S is a straight line. You would say angle ACO plus angle OCD is making 180 degree. Then linear pair angles. Then it is known as a linear pair angle. From here, you need to understand that when there is a perpendicular, then this side will be equal to this side, and angle of perpendicular is always 90 degree. So I hope something you understood from this. Now we are going to discuss theorems based on this. So here first theorem is saying there is a circle. And it is saying, first theorem of the circle. I will not be writing all these questions. Instead I will be speaking, and I will be explaining that how this is, how can we say that this is correct, this is how to define. Okay. So here first theorem of the circle is saying there is a circle, and here there are two chords. Which measure is equal to each other. So measure of one chord, let's say measure of this chord. Okay, measure of this chord. There are two chords, and in that it is saying this looks smaller. It is saying measure of this chord is 3 centimeters. So measure of this chord is also 3 centimeters. The theorem is saying, I am not saying. So there are two chords which measures of both chords are equal to each other. Now, from now two lines there will a four mesh sector. So how it will be possible when there will be two radius? Okay, chord is not radius. Always remember, chord is not radius. So there will form two sector by two chords. This is what the theorem is saying. We can name A, B, C, D. Okay, we can name. Now here theorem is saying. So this will be the measure of this will be equal to measure of this. This is what the theorem was saying, and we can say yes. This measure of this will be equal to measure of this, of course. So as we know, this is also equal to each other. So here this will measure of this. If measure of this radius is 4, then measure of this would be 4. But this will be something else. And chord is measure of a chord is 5, then this will be 5. This is what first theorem was saying. Second, from here you will be understanding is that all given radius of a circle, measure of all those radius will be equal to each other. But when it comes to something else, for example, chord line segment. So this chord, measure of this chord will be equal to measure of this chord. Okay, this is what theorem was saying. Now next theorem is secant theorem. You can also add. You are crystal clear what I taught you. So here there were two angles subtended by two radius. Subtracted angles at center, and from here measure of this chord, measure of this chord will be equal to each other. Theorem second we have a same. Which was like that. This was a circle, and here there was a chord, and one line segment was coming from the center, was hitting the surface of the chord. So here this angle was forming 90 degree. This angle was forming 90 degree. This angle also was forming 90 degree. And here it is saying that this line segment will be bisecting, because both parts are equal to each other in order to measure. Now measure of this side will be equal to measure of this side. Okay, yes, this line is perpendicular to this line, and measure of this angle would be equal to measure of this angle. Here this line is a straight line, so here there is a linear pair. Sum of this angle would be 180 degree. This is what is a linear pair. So we have seen this as a theorem 2 before this theorem 1 discussion. Now I am moving on third theorem. Theorem number 3. Third theorem is saying the perpendicular from the center of any circular chord bisect chord. Third is also we have seen. Third theorem is saying a perpendicular. So perpendicular, a line which is a perpendicular is coming from the center. It bisect the chord. So of course it is saying measure of this side, measure of this part will be equal to measure of this side. It is a true. Okay, it is a true. Now next theorem. When it comes to bisect, then you already know that both parts will be equal to each other in order to measure. in order to measure. So fourth theorem is also saying that there is a line which is a bisecting the chord from coming from a center is a perpendicular. Of course, this is making a 90 degree. So this is also, when it comes to 90 degree, then it is also known as a perpendicular. And OB is a parallel to OB is a perpendicular to AB. Clear? So I think it is similar. This is the similarities from the previous theorem. Now fifth theorem will be interesting. Fifth theorem is saying there is only one a circle which will fall on collinear, a circle which will pass all the non-collinear points. So here, let's start from one. This is one point. Can a circle pass this line? Pass this point? Of course, this can. Not only one circle. Unlimited circle can pass this given point. So unlimited circle can be passed from this given point. Now, what about 2? So how much? Of course, only one circle can pass these 2 given points. Only one circle. So only one circle, nothing else. When it comes to three points, then how much circles can a circle pass? Can a circle contain all these 3 given points? Of course no. Only a line will be able to contain these 2, and here you can say this 2. But what about this? So here 3 collinear, and collinear, which means when it comes to points, then points are in state. If there are more points than one are in state, will be collinear points. But theorem is saying that there will be only one. There will form only one circle on given 3 non-collinear points. So let's apply 3 non-collinear points. So these are that are not in a straight line. So here one line can be drawn, only one line, and this is what the theorem is saying. So of course, yes, it is true that one line can be drawn. This is not exact diagram of a circle. So only one line can be formed, only one. Okay. The theorem number 5 is the same. So non-collinear points on only one circle can contain all those non-collinear points. Now next. Next question which we have to prove. Question is here I will draw direct a diagram. Question is saying if a line intersect two concentric circles. So concentric. What is the meaning of concentric circles? It is saying that there can be more circles which measure of radius will be same. Will be same. What is it saying? Radius will be not same. Radius will be like that. This is one, and there are two circles, and radius starts from this same circle for both circle. So center will be same for both this circle. So from here to till here, this is radius for this circle, and from here to till here is a radius for this circle, for big circle. Okay, this is what is the meaning of concentric circles. There can be circles which center will be same for all those circles. Is the meaning of a concentric circle. Now, question is saying if a line intersect, this was meaning of a concentric. There are okay. If a line intersect two concentric lines circle with the same center, with the center O. So a line is intersecting this center. A line intersecting the two concentric radius from a center. Okay, clear. Now at ABC. So here this line is intersecting here A, B. This is a C, D. We can see how much intersecting. How much this line is intersecting? 1, 2, 3, 4. There are 4 intersecting view. So we have to prove that AB is equal to CD. This is what question is saying, that you have to prove that AB, measure of AB from here to till here is equal to from here to till here. How can we prove? But one point more. Not passing the center. Question is not saying that passing the center. Question is saying there are two circles, and both of them circles are intersecting like that. This is the center. So here this is the intersecting view. Now this measure of this side is equal to measure of this side. AB is equal to CD. We have to prove this. So here this is O. Here a line can be drawn, can be constructed like that, which will form a perpendicular like that. Okay. So here can we say OL. Let's say OL. OL is a perpendicular to BC. Whatever we are observing, we have to write. If we can prove this, then so OL is a perpendicular to BC. Next is OL is also perpendicular to AD. We are starting from this. So here BL. So as we know, OL is also bisecting line segment. So it is a bisecting BC chord. So which means BL, measure of BL is equal to measure of LC. Okay, LC. Now this, in this case, OL perpendicular to AD. OL perpendicular to AD. So in this case, this is a bisecting. So a measure of AL will be equal to measure of LD. In this case, okay, AL is equal to LD. Here you can see. Now, even you can apply this is where this is one equation, this is a second equation. This is one equation, this is a second equation. Now, from 1, let's subtract this from 2. For example, AL minus BL, AL minus BL, and LD minus LC. So what will left? AL minus BL will be what? AB, AB, and LD minus LC. It will go on. Then it will be left. So CD. You can see we have proved. We have proved. Okay. How? You can see we have subtracted this from AL. Then we go to AB line. We have subtracted LC from LD. Then we have got CD. You can see. Just have a look. Then I will move on. Next question. Next theorem. Next theorem is saying that angle subtended by an arc in a circle. This is okay. Now we have seen this, but again I wanted to explain this. Angles subtended by, angles subtracted by, you can say separated by angles subtracted by arc. So here you can see this arc, okay, this arc. In this sector we can draw how much? We can form angles how much? So here at the center we can draw one angle, okay, one angle, and here we can draw secant in segment and segment, in minor segment we can draw, and in remaining part which is coming in major sector. In major sector can be drawn a triangle, this angle. So as we know, this is 40, then it will become, this will become 20. This is what? This theorem is the same. Theorem number 8. Theorem number 8 of the circle. Okay. There will be formed three angles. Three angles of a triangle. First will be at center, second will be in segment, third will be in major sector. In major sector, otherwise you can say in major segment. And this which is at the center is coming in sector, in minor sector is also coming, not only in sector. Only in sector, okay. This is what theorem number 8 is saying. Now let's move on to the next. Next is what? Quadrilateral is given in line segment. Quadrilateral is given in line segment. So here I would like to explain. There is one circle. Now in this circle there is a quadrilateral. So quadrilateral can look in different like that. Where a quadrilateral will have 4 angles. It is the meaning of a quadrilateral. So quadrilateral has 4 angles, has 4 vertex, has 4 line segment, has 4 interior angles, has 4 exterior angles. So here it has also 2 diagonals. So this is saying that there is how much? 4 angles. There is 4 angles. 1, 2. So you can name A, B, C, D. There are 4 angles. Okay. So here it is saying already we are aware. What we are aware that sum of all interior angles of a quadrilateral is also sum of all interior angles of quadrilateral. quadrilateral. Quadri which means four, lateral which means sides, is always a 360 degree. Whereas whereas this will form how much? 180 degree, and this will form 180 degree, and 180 will become 360. You can write angle A plus angle D will form 180 degree. It will happen in quadrilateral when there is a shape of a quadrilateral. So angle C addition angle B will become 180 degree, and sum of both will become 360 degree. So here like that will happen in shape of a quadrilateral. Otherwise you can say interior angles, alternate interior angles. Now we have a question. We have to find a angle. We have questions based on this. Now, a diagram is given of a circle. It looks like this. This is a diagram of equation, and equation is the same. First of all, let's read the equation. Equation is saying in a figure below, this given figure, A, B, and C are 3 points on a circle. A, B, C, 3 points on a circle. Okay, with the center O. Okay, such that angle BOC forms a 30 degree, and angle AOB forms a 60 degree. If D is a point on the circle other than the arc ABC, this is arc. So here on the other side of this arc is a what? A D point. So the arc ABC and find angle ADC. So simple, ADC. We have to find this angle. Okay. It is a very easy. We will apply theorem. Whatever we have seen. So here, this is forming a triangle, isn't it? We can construct a chord here. You can see. Now, this is forming a triangle in where? In a major sector. So we will sum up this. It will become how much? So you can write. We have to find this angle. Okay, can we write angle AOB is forming how much? 60. So angle COB is forming 30. Sum of this will become what? Angle AOC will become how much? 60 plus 30. You already know. It will be 90. If this angle is 90, which is at 0, at 90, then already now by theorem 8, I think. Theorem number 8. So theorem number 8 says that theorem of the circle says that if a angle subtended, a angle which is making at center in a triangle is how much? It's 90 degree. Then in the remaining part of the circle, which is forming a triangle in a major sector. So this is a 90, then this will become 45. This is what the theorem of the circle says. Okay, so here by the theorem you can say, by the theorem of the circle, you would say that if angle AOC, so here this will become half of AOC. Okay, of AOC. So it is what AOD, not ADC. So this equal to this AOC, angle AOC. So here AODC. So 1/2. What is the value of this angle? Is a 90 degree. It will become 45. So here angle D is 45. So we have applied a theorem. This by theorem we were able to identify measure of this degree. Now next question. Answer is correct. A chord of a circle is equal to radius of the circle. Find the angle subtended by a chord at a point on the minor and also at on a major. Next question I would like to write. This is what is it. This is what the question is saying. Question is saying a chord of a circle. Let's draw a chord of the circle. This is chord. A chord of a circle is equal to radius. So when it comes to this is also radius. So measure of this radius is 7. Then measure of this radius is also 7. Okay. Where AB is a chord, so AB is also radius, because question is saying measure of radius is something, then measure of a chord is also equal to radius. So a chord of a circle is equal to radius of the circle. So if this is 7, this will be 7 and this will be 7. When and now here you can say there is a twist. What? There is a twist. Twist is that if all sides of a triangle is equal, all measure of all sides of a triangle are equal to each other in order to measure, then we can say, we can name that a triangle what as a equilateral. So we can say that this is equilateral triangle. So when it comes to equilateral, we already know that all interior angles of equilateral triangle will form 60 degree. 60 degree. When it comes to equilateral triangle. Okay. Now, what is the saying? That find the angle subtended by the chord. Subtended by the chord. So here, by the chord at a point on the minor arc. So this is 60 and also at a point on the major arc. So we have found this is 60, now 60. Now a angle which is subtended in minor arc, in major arc. In minor arc is 60 at a point, at a point. Now here we know that it will be how much? 30. It will be how much? 30. So angle O is a 60. Then you can say angle A will be how much? 1/2 LO. So angle L will be 30. So it will be 30. Okay, it will be 30. Clear? What else? So we had to find the measure of this radius and a point. We have found this measure of this and measure of this. We have found this by equilateral triangle. Now, what about this? What about this? Okay, what about this? This angle. Here you can see this can form what? Like that. Is forming. So we have a quadrilateral. Here I can do a separate like that. Okay, like that. This is chord. This is coming in chord in segment, and this is coming in major arc, in major sector. This is 30, whereas this is 60. No. Okay. This is 30. This is not 60. This total is not 60. But here we can found if this is 60. So okay, question is saying find measure of this. So already now what this is quadrilateral. Then angle A, angle B will form 180. So angle is at 30, and we don't know angle B. So here we will get a measure of angle B. 180 minus 30, it will become 150 degree. So angle will be 150 degree. This will form 150 degree. So we have got a measure of this, measure of this, measure of this, measure of this by this question.